finally, in part 4, we look at the loudspeaker, which is down at the bottom. Another picture courtesy of Big England. And this picture is actually made up of two elements. The first one on the left is the 3D picture, and the second one on the right is a 2D cross-section. So you've got to imagine that the whole thing has been chopped in half right through the middle. Now, the first thing to get your head around is that there's a very unusually shaped cylindrical magnet. This one has got the North Pole's on the outside in a ring and the South Pole in the center. So the field lines go from North Pole to South Pole. So they go, it's a little bit small. Can I make it a bit bigger? Let's make it a little bit bigger. Why not? And so the field lines go from North to South Pole like that. So if we were to be able to see them in here, they'd be going like this, and then like this. So they go all the way around, and all the field lines go from the outside ring, the North Pole, to the central rod, which is the South Pole. But hang on a minute. We've got a coil. We've got a coil. And the coil is going round and round in the groove in the cylinder of the magnet. So we've got a current here, here, here. Now, I don't know which way this current is going. So I'm just going to assume that I've got first finger field going from north to south, and then I've got the current. The current on this side, I'm going to assume is going into the page, which we saw was a cross, and therefore the force on this side is outwards. But what about the other side? Well, if the current is going in on this side, then it's going to be coming out on the other side. But the magnetic field's also coming in the opposite direction. So two wrongs do make a right in this case, and you get the force on that side is also outwards. So with the current going in on this side and out on the other side, we're going to get a force pushing the coil outwards. Now the coil is then attached to this paper cone that you can see. And this paper cone pushes the air backwards and forwards. Well, why does it go backwards and forwards? Well, the answer is because the current in the coil isn't DC, it's AC. We know that if we're going to make a sound, anything that vibrates makes a sound. If we put AC into the coil, then the force will be outwards, then inwards, then outwards, then inwards, then outwards, then inwards. Every time the current reverses, the force will reverse. And this is exactly what we need to make sound. So the only remaining question is, what current do we put into the coil? Well, if you just put a rather dull sine wave, then it'll make a sound a bit like this. But if, on the other hand, you want to have the Spice Girls or whoever is your favorite, then what you do is you feed in the current that might have Spice Girly type sounds superimposed upon the basic. And every time the current changes, the force will change and the cone will move in and out. So bingo, loud music is on the way. But the crux of it all is this very strangely shaped cylindrical permanent magnet. You may have noticed it. Sometimes, if you find a loudspeaker like this, you can find that there's a pair of scissors or something stuck to the back of it, because things do stick on the back of them. Okay, so that ends DC Motors. Thank you very much for listening.